Good morning, evening, or afternoon. How you doing? Welcome back to Mr. Morrow's class, Mr. Morrow's Algebra 1 and 2 class, actually. I was just going over the quiz results, and I wanted to make sure that everyone understood how to complete the process of simplifying and or multiplying and dividing rational expressions. So I'm going to go one by one here. Okay, for the first one, we're dealing with A. The directions say evaluate the expression for the given values. Remember that evaluate means plug in. So you're going to plug those values in, and then you're going to go ahead and simplify them, solve them. So for number one, I've got 2 times x, which in this case is 1 squared, minus x, which is 1, minus 3 over x, which is 1, plus a negative 2, which is y, so minus 2. This is going to be 1 squared is 1 times 2 is 2. 2 minus 1 is 1. 1 minus 2 minus 3 is negative 2. Over 1 minus 2 is negative 1. So my answer is 2. For 1b, I've got 2 times x, which is 5, squared, minus x, which is 5, minus 3, over x, which is 5, plus y, which is a negative 4. 5 squared is 25, times 2 is 50. 50 minus 5 is 45. 45 minus 3 is 42. 5 minus 4 is 1. So my answer is 42. Okay? So hopefully that makes sense for everybody. Let me go ahead and just shrink this so we could keep the answers up. Okay, we'll keep it up here in the corner. All right, number 2. Simplify/perform the indicated operation for each rational expression and find the values of the variable for which the rational expression is undefined. Remember, an expression is only undefined when there is a 0 in the denominator. So I don't have to worry about anything that's going on in the numerator. But if there are any variables in the denominator, I must set them to 0. Okay? And that's the value that it cannot be. That's the value that makes it undefined. So just to save time, let's move this guy over here. Okay. Let's do this. Let's factor this guy first. So I've got plus 3 and plus 5. 5 times 3 is 15. 5 plus 3 is 8. Divided by. Okay. I have a Cuban method here, so I'm going to do my Cuban method over here because I know that I'm going to have to imaginary factor. 2 times negative 3 is negative 6. What times what is negative 6, but when I add it together is 5. That's going to be positive 6 and negative 1. 6 times negative 1 is negative 6. 5 plus a negative 1, 6 plus a negative 1 is 5. Artificial factor at 2. So I've got x plus 3 times 2x minus 1. Goodbye, goodbye. My answer is x plus 5 over 2x minus 1. Okay, there is a variable in the denominator, so I must set that not equal to 0 because I don't want the denominator to be 0. So x will equal negative 1. X will not equal negative 1/2. It cannot equal that. That's my restriction. Okay, this is my answer. And this is my restriction. X cannot equal negative 1/2. Okay. Hopefully you got that. We'll go ahead and try to shrink this up as well. All right, let's see if we can make this work. Okay, perfect. We'll shrink this guy up over here. And we'll put it over here for now. Actually, let me go ahead and erase this for you. Okay, perfect. Okay, next. We got this bad boy right here, number 3. All right, let's factor each of them, and then we're going to have to do a state change flip because remember, this numerator is being divided by this denominator. Okay? So we got to do a state change flip. So I'm going to first factor everything, and then I'll do the state change flip. So this guy here, what times what is 30, but when added together is a negative 11. We got negative 5 and negative 6. What times what is 15, but when added together is negative 8. That's negative 3 and negative 5. Denominator, what times what is negative 6, but when added together is negative 5. I got negative 6 and 1. And what times what is 7, but when added together is 8. I've got 7 and 1. So, okay, extend the page here. Now let's go ahead and do a stay to the numerator. Change division and multiplication. Flip. We're going to flip the denominator. So numerator, first fraction, stays. That's my stay. That's my stay. Because that's in the numerator of this complex fraction here. Change. We're changing the multiplication. Flip. I'm going to flip the denominator. So that means I'm going to rewrite it as x plus 7 times x plus 1 over x minus 6 times x plus 1. And now the fun part. All right, see you later. Goodbye, 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 goodbye. My answer is x plus 7 over x minus 3. And you do not have to worry about the numerator, but you do have to worry about the denominator. So I must set x minus 3 not equal to 0. So x cannot equal 3. That's my restriction, and that's my answer. Okay. Let's go ahead and keep this one as well for everybody. Let's go ahead and group it. Okay. Sorry I'm making this so small, but remember you can pause, rewind, whatever you need to make it work for you. Okay. Next. Let's do number 4. Okay. For number 4, pretty simple. The numerator here of the first fraction, that just stays the same for right now. Got 4p squared over, I'm going to factor the first denominator. So what times what is negative 18, but when added together is negative 3. Hopefully you said negative 6 and positive 3 times p plus 3, that can't be factored, over 8p, which cannot be factored either. Now at this point, let's just do some reducing. I can get rid of p plus 3 and a p plus 3 because they're both identical binomials. But 4p squared and 8p are monomials, so they can be reduced. So I can take a p from the denominator here. So I take 1p from the numerator, leaving me with 1p in the numerator. 4 goes into 4 one time. 4 goes into 8 two times. So my final answer is going to be p over 2 times p minus 6. I don't have to worry about the variable in the numerator, but I do have to write the restriction for the variables, if any, in the denominator. So here I have a product. Remember the zero product property. If a times b equals 0, then a equals 0 and or b equals 0. So in this case, 2, of course, cannot equal 0, but you got to write all the factors out. And p minus 6 cannot equal 0. So my restriction is that p cannot equal 6. You don't have to worry about 2 does not equal 0 because that's already a true statement. So this is my answer, and this is my restriction. Okay. Let us continue. See if I can group everything now. Okay. Alrighty. Perfect. Okay, next. Number 5. Okay, number 5, I threw a little different type of factoring at you. It's just grouping. So this is a good review of factoring as well as solving or rather simplifying rational expressions. I'm going to first factor out an n squared from that first grouping that I did, leaving me with an n minus 4. And from the second binomial, I'm going to factor out a positive 3, leaving me again with an n minus 4. Remember, that is your goal, to have this guy and this guy identical. Now, this is all being divided by what times what is 16, but when added together is negative 8, negative 4, negative 4. So now, remember, this guy and this guy must be factored out to one value. And then what do I have? The leftovers, which is my second binomial. Now that's over n minus 4 times n minus 4. I can cancel an n minus 4. My answer is n squared plus 3 over n minus 4. What is my restriction? N cannot equal 4, because if n equals 4, the rational expression will be undefined. Okay. All right, next. 6. 6 actually I could do right here. Okay, here I've got a division, so please remember, stay, change, flip. Sometimes people want to factor it, and that's fine as long as you remember to stay, change, flip. If you are like me and sometimes forgetful, just go ahead and stay, change, flip from the beginning. So let's just do that. Stay, change, flip. Now, why do I like to do that? Because now I'm done. My forgetfulness will not affect me at this point. I'm already in the correct setup. So now let's factor. That's y minus 3 and y plus 3, because that's a difference of squares. Okay, this guy, I'm going to have 2y, 2 times negative 15 is negative 30. So it's going to be negative 6 and positive 5, but I can artificial factor a 2 here. So that's going to be y minus 3 times 2y plus 5. And over here, I'm going to have two Cuban methods, 2 artificial factors. So I'm going to go ahead and do them here and transfer the artificial factor, the complete answer, to the bottom. So I'm going to have 2y, 2y. 2 times negative 10 is negative 20. I'm looking for plus 1, so positive 5 minus 4. Factor out a 2 imaginary factor. So I got 2y plus 5 times y minus 2. Next one. I got 3y and 3y. 3 times 3 is 9. So it's going to be positive 9, positive 1, because I'm looking for 10, the sum. Artificial factor of 3. So I got y plus 3 times 3y plus 1. Now it's the fun part. I can cancel. Y minus 3 and y minus 3, goodbye. Y plus 3, goodbye. 2y plus 5, 2y plus 5, goodbye. My answer is y minus 2 over 3y plus 1. My restriction is y cannot equal negative 1/3. Okay? And then last but not least, number 7. Thought actually was one of the easier ones. Okay, let's go ahead and see what we can do here. First, let's factor out that numerator. I'm going to factor out a 5, giving me an x minus 3 over what times what is negative 12, but when added together is negative 1. We're looking at negative 4 and positive 3. What times what is 8, but when added together is negative 6. We're looking at negative 4, negative 2. And now this guy. Remember what we had talked about. We want to make x positive. So I'm going to factor out actually a negative 1, which is then going to allow me to rewrite this as x minus 3. Because if I divide a negative 1 here, the 3 becomes negative, and the x becomes a positive. So now, x minus 3, goodbye. X minus 4, goodbye. So I'm going to be left with 5 times x minus 2 over negative x plus 3. Just out of habit, I like to always write the negative in the numerator. So go ahead and make it nice and professional. Negative 5 times x minus 2 over x plus 3 is my answer. And my restriction, x cannot equal negative 3. I hope this review of the quiz helped out, and I hope you learned something. Go ahead and watch it over and over. Remember to pause. Have a great day. Thank you.